GraphQL and when to use it. Hi, I'm Shakaranski, and there is my dog, Kindle. I'm a software developer at Salto, and I use GraphQL every day, both in the backend and in the frontend. But enough about me. Let's talk about you. If you were Mark Zuckerberg in 2003. So, you are developing Facebook, and specifically, the most important part of Facebook, which is, of course, the feed. And let's say you are using REST API. Recall that REST API is an architectural style for web APIs, where we usually use HTTP methods to either get, create, update, or delete various resources. So how would you design the API for the feed? You'll probably have a /posts endpoint that returns a list of posts, where each post has text and creation date and many other details. And this works just fine. And after some time, you decide that you want to increase engagement, and you have an idea to add comments to the feed, because you believe that if people will see comments, then they'll want to comment even more. So you want to show the top 2 comments of each post right there on the feed. How would you design the API now? You'll probably just add a comments field to the /posts endpoint. And this works just fine. And after some time, you decide to hire a product manager. And she looks at the site and has this great idea. Remove comments, because the feed is too cluttered and it should be nice and clean. So, what would you do now? You can just not show comments on the feed, but if you are still returning them from the backend and calculating the top 2 comments of each post, then it's pretty wasteful. So you want to not return comments from the backend. But this is a breaking change in your API, and it also requires some work in the backend. Anyway, you decide to do this change. And maybe you are creating a new API version just for this. And when you're done, your product manager comes with yet another great idea. Add comments, but only for the website, because the app should still be clean. What would you do now? And note that this is not an easy question, because there are many possible solutions, but they all have disadvantages. And let's go over some of them. So, solution number 1. The /posts endpoint won't return comments, and then in the website, you'll have to ask for the comments of each post separately. This is called underfetching, because the /posts endpoint doesn't return all of the data that you need. And having to send these many requests, in fact, 1 request per post in the feed, is both slow and inconvenient. So let's take a look at solution number 2. The /posts endpoint will return comments, and then in the app, you just won't use them. This is called overfetching, because you are fetching more data than you need. And it wastes time, because your backend has to calculate the top 2 comments of each post, and then you are just not using them. And it also wastes bandwidth, because you are sending these comments to the client, and the client doesn't need them. It can even waste your client money, because some clients pay for the bandwidth. So let's look at solution number 3. You can have a parameter view, and in the detailed view, you will return comments, and you will use it in the website. And in the standard view, you won't return comments, and you'll use it in the app. But the thing is, there are many possibilities. Maybe you want to show the top likers of each post, and maybe you don't. Maybe you care about the author, and maybe you don't. So you will end up having many views, like simple and simpler and full. And each view will be coupled with your frontend at that specific point in time. So for example, if the detailed view includes the top likers of a post and the standard view doesn't because you don't show that information in the app, and then you decide that you do want to show top likers in the app, then you'll have to change your backend to return top likers in the standard view, even though it already returns top likers in the detailed view. So every change in the frontend will be coupled with a change in the backend. And in the end, you'll have so many views, you won't even remember which views you have and which values each view returns. So this is both confusing and not scalable. And the thing is, you can count on your product manager to keep having these great ideas, like to show the top likers of each comment, or to support Smart TV, which is a completely different view, or to support external API consumers, meaning people that are using your API for needs you don't anticipate in advance. And that's why your backend has to be convenient for many use cases. So let me introduce to you GraphQL. GraphQL stands for Graph Query Language. And I'll first explain some main concepts in GraphQL, and then I'll explain how GraphQL solves all of the problems that we have just discussed. The first main concept in GraphQL is the schema. A schema is basically a description of your API, and every GraphQL API must have a schema. So in our case, this is what a schema might look like. First, we have our top-level type, query, and in there we have our top-level queries. So we have the posts query, which returns a list of posts, and the single post, which receives an ID and returns a post with this ID. Exclamation mark stands for not nullable. Now the post type has ID, text, and a list of comments, and the comment type has ID and text. Having a schema has many benefits. First, it serves as a type system. So GraphQL can automatically generate from your schema the types in your own language. For example, it can generate the post and the comment type and many others in C# and Java and TypeScript and many modern languages. Another benefit of having a schema is that it serves as a contract between the client and the server. So when you are about to develop a new feature, the front-end developer and the back-end developer can first decide on the schema together, and then they can start developing the feature simultaneously because they already know what the API is going to look like. The third benefit of having a schema is that it allows introspection, meaning that when I'm about to use a new GraphQL API that I don't know, I can just read the schema, and that will provide me with all of the information I need about which queries I can make and which return values I'm going to get. In fact, how do you query a schema? Simple, you just send a post request to /GraphQL. So there is only one endpoint, /GraphQL, and you can get everything you need from that endpoint. And in the body of the request, we send the specific query that we are after. In this case, we want the posts, and for each post, we want the text and the comments, and for each comment, we want the text of the comment. The result of a query looks exactly like it. So in this case, we have a field data. Inside, we have posts, which is a list of posts. Each post has text and comments, which is a list of comments, and each comment has text. Now, if you don't want to show comments anymore, then you can simply not ask for them, and then the backend won't return them, and it won't even calculate them. This depends on the backend implementation, but it's very easy to implement this way. So the backend will only calculate comments when you explicitly ask for them. So as you can see, GraphQL solves many problems. It helps you avoid breaking your API, because if you don't want to show comments anymore, you can simply not ask for them, and there is no need to change the API at all. The schema remains the same. In addition, GraphQL solves overfetching and underfetching, because you get exactly what you ask for. Now, you may be asking yourself, how does it work? How come GraphQL only calculates comments when you explicitly ask for them? How is it implemented? Is this magic? Well, no, it's resolvers. And let me show you the TypeScript implementation of the resolvers for our case. So first we define this object, which describes our resolvers. So our top-level resolvers are post and posts, and we also have a resolver for comments, which is a field of the type post. Note that we don't have a resolver for text, for example, because in this implementation, we will always calculate the text of a post, but we will only calculate the comments of a post when you explicitly ask for them, and that's why we have a resolver for comments. Now, what is a resolver? A resolver is just a function. And let me show you some examples. So first, the posts resolver. It doesn't need any arguments, and it returns a list of posts simply by calling another function all posts, which is probably querying our database and maybe doing some more logic, and then it returns a list of posts. And note that we are only asking for the ID and the text fields of each post, because at this point, we are not calculating comments just yet. That's why we have the comments resolver. And this resolver will only run when you explicitly ask for comments. Now, this resolver receives one argument, which is the post that these comments belong to. And in general, every resolver can receive its parent as an argument. The parent of comments is post. And then the resolver just returns a list of comments by using the ID of this post. The third resolver, which is a single post, is very similar, so I won't show its implementation here. But as you can see, implementing resolvers is very easy, and GraphQL is very powerful. So you may be asking yourself, is GraphQL perfect? Well, no, but I won't go over its disadvantages in this short presentation. However, I will mention two challenges that I have experienced with GraphQL. First, the learning curve. Because to learn GraphQL, I first had to study the specification of GraphQL, and then I had to learn the specific implementation that we are using at Salto, which is a TypeScript implementation. And for that, I had to learn both a package for the backend and a package for the frontend. And since GraphQL is very different from REST, there was quite a lot to learn. The second challenge is the maturity of GraphQL, because GraphQL was initially released to the public about 5 years ago, and its stable release was about 2 years ago. So it's not as mature as REST. However, the community is very active, and GraphQL is maturing by the day. In fact, who is using GraphQL? Many companies, like PayPal, Twitter, Airbnb, GitHub, and of course, Facebook, who invented GraphQL. And they're using GraphQL for a good reason, because as you've seen, GraphQL solves real problems. It helps you avoid breaking your API, and it solves overfetching and underfetching. So the next time you are designing an API, I hope you consider using GraphQL. Thank you.